Okay, so this is a question from section 8.2, number 12. It's supposed to be 8.2, okay? Section 8.2, number 12, integration problem. Here is the question: cosine to the power 4x divided by square root of 1 minus sine x, and the integration is from 5 pi over 6 to pi. So how do you find this type of integration? So first of all, we have to simplify this expression we have given here, and there are the first simple way is just multiply this term on the top and bottom by conjugate of this square root of 1 minus sine x, which is square root of 1 plus sine x. By doing that, as you can see here, if you multiply both sides, top and bottom part, this bottom part becomes square root of 1 minus sine square x, which is eventually cosine square x. And square root of cosine square of x is one thing you have to keep in mind. This is not, it doesn't look very trivial. Square root of cosine square of x is negative cosine of x, and that is from this definition. Square root of x square is negative x if x is negative, and it's equal to the positive x if x is positive. Okay, so since this angle, the limit of here you can see the range of integration 5 pi over to the pi, 5 pi over 6 to the pi, which is on the third quadrant. So when you try to draw that, 5 pi over 6 is somewhere here, and pi is, so the integration goes from here to here. So that means we are working on the second quadrant, not the third one, sorry. Second quadrant, the quotient function here on the second quadrant is negative, because quotient function means it's a what is that, it's a x coordinate of the point. So if you check the quotient function on the second quadrant, it's always negative. Because of that, this square root of cosine square of x is negative cosine of x. This is very tricky part, so you have to understand this definition. Okay, square root of x square is negative x if x is negative itself, and it is equal to the positive x if x is positive itself. Okay, by using that fact, now we change the problem from this problem to this problem. Okay, now we can find the integration by using substitution rule. So here a little bit complicated term, as you can see, is it's a square root 1 plus sine x. So we can just substitute u equal this value, u equal 1 plus sine x, and if you just find the derivative, du equal, the derivative of 1 is 0, and derivative of sine x is cosine of x dx. So now we have to change this the limit of integration. So when x is pi over 6, u equal 1 plus sine 5 pi over 6, which is eventually sine of this is half. So if you add this two number, it will give you 3 over 2. And when x is pi, u equal 1 plus sine pi means 0, so u equal 1. So this range of integration now becomes 3 over 2 to 1. Okay, but before that, after substituting for 1 plus sine x, we also have to substitute for this cosine x, and one of the cosine of x goes with the dx, and that can be replaced by du, but the leftover would be cosine square of x. So now we can change this cosine square of x into 1 minus sine square of x, which is eventually 1 plus sine x times 1 minus sine x. And we have assumed that here, this is our assumption, 1 plus sine x equal 1. So 1 plus sine x equal u. So we can replace this thing by u, but we still have 1 minus sine x. So we can find out the value of this expression in terms of u. Remember, we are converting everything from x to u. So if you go back here and you can check here, sine x equal u minus 1 if you subtract 1 both sides. That's what I'm doing here. I'm just substituting sine x equal u minus 1, and after doing the simplification, it gives me 2 minus u. So there is this problem of integration now changed to this negative sign, 3 over 2 to 1, u times 2 minus u times square root of u times du. But as you can see here, 3 over 2 is greater than 1, so we can change the limit of integration. We can just flip it, And we know flipping means, it's if you just go from A to B to B to A, the only thing is you have to put one extra negative there, right? So because there is already negative here, so by putting this negative after flipping this limit of integration, that becomes positive. And now our problem is this one, and everything, as you can see here, is just a u to the power something. So we can use the power rule of integration for the u, and this is the coming from power rule of integration. And then by using the fundamental theorem, first time plug u equal 3 over 2 for both of them, and minus u equal 1 for both of them. You just have to do the simplification. This 5 over 2, just you can flip it and it becomes 2 over 5, because 2 is already there, so 2 times 2 is 4 over 5, 3 over 2, 5 to the exponent 5 over 2, minus this 7 over 2 is 2 over 7 after flipping, and if you replace u by 3 over 2, that would be 3 over 2 to the power 7 over 2. And now you have to plug u equal 1 in this expression, minus 4 over 5. This minus and minus from the formula becomes plus 2 over 7. And if you just simplify this 2, it will give you negative 18 over 35. So that's your final answer. So for this type of problem, you have to keep in mind some of the things, like you have to first multiply this expression by its conjugate. You have to use substitution, and then when you substitute, you also have to make sure that there is a rule of this square root of x square. You also have to keep in mind this rule. Okay.